Understanding circuit loading is crucial for safe and efficient electrical system design. The National Electrical Code, or NEC, provides guidelines for the maximum allowable load on a circuit, but it's essential to consider other factors beyond the code minimums. The NEC generally permits continuous loads up to 80% of a circuit's rating. However, adhering strictly to this maximum can sometimes lead to problems. A safety margin is necessary to prevent overloads and potential electrical hazards. Operating close to the 80% limit leaves little room for unexpected load increases or fluctuations. Voltage drop is another critical factor. As the load on a circuit increases, the voltage of the equipment can decrease. Excessive voltage drop can negatively impact equipment performance, reduce its lifespan, and even cause it to malfunction. Staying below the 80% threshold helps mitigate voltage drop issues. Equipment lifespan should be considered when determining circuit loading. Running equipment at or near its maximum rated load for extended periods can accelerate wear and tear, shortening its operational life. Maintaining a lower load percentage can prolong equipment lifespan and reduce maintenance costs. In the case of a server rack installation, where equipment typically runs continuously, these considerations become even more important. It is generally recommended to aim for a load percentage of around 60 to 70% of the circuit rating. This provides a more comfortable safety margin, reduces voltage drop, and helps extend equipment lifespan. When calculating the load, it's crucial to use accurate amperage values. Nameplate ratings can sometimes be misleading. Actual operating amperage should be measured under typical conditions to get a realistic assessment of the load. Also, remember that the 80% rule applies to the overcurrent protection device such as a circuit breaker. The circuit breaker's ampacity must be adequate for the non-continuous load plus 125% of the continuous load. For example, if a circuit has a continuous load of 16 amps, the circuit breaker must be rated for at least 20 amps. Using a 30 amp circuit for 12 servers, each drawing 1.9 amps at 208 volts, results in a total load of 22.8 amps. This represents 76% of the circuit's capacity, which is relatively close to the 80% limit. While technically within code, it's advisable to aim for a lower load percentage for the reasons previously discussed. Here are some options to consider for managing circuit loading in a server rack installation. Firstly, use a 30 amp circuit as planned, but install a current monitor to ensure the load does not exceed 67% or 20.1 amps. Secondly, install a larger circuit, such as a 40 amp circuit, to provide a more generous safety margin. Thirdly, consider using multiple smaller circuits to distribute the load more evenly. Installing a current monitor provides real-time feedback on the circuit load, allowing for proactive management and preventing overloads. Using a larger circuit provides a greater safety margin and reduces the risk of voltage drop. Distributing the load across multiple circuits can improve overall system reliability and reduce the impact of a single point of failure. When selecting conductors for the circuit, it is important to choose the correct wire gauge based on the ampacity requirements. The National Electrical Code, or NEC, Table 310.15b16 provides guidance on conductor ampacity based on insulation type and temperature rating. It is also crucial to consider directing factors for ambient temperature and the number of current carrying conductors in a raceway or cable. Higher ambient temperatures and multiple conductors in a raceway can reduce the ampacity of the conductors. Proper grounding is essential for electrical safety. All equipment should be properly grounded to provide a low impedance path for fault current. The grounding system should comply with the requirements of the National Electrical Code, or NEC, Article 250. Surge protection is also recommended to protect sensitive electronic equipment from voltage spikes and surges. Surge protective devices, or SPDs, should be installed at the service entrance and the downstream distribution panels to provide comprehensive surge protection. Power quality is another important consideration. Harmonic distortion, voltage fluctuations, and other power quality issues can negatively impact equipment performance and lifespan. Power conditioning equipment, such as line conditioners and uninterruptible power supplies, or UPSs can help improve power quality and protect sensitive equipment. Regular electrical inspections are essential to ensure the safety and reliability of the electrical system. Inspections should be performed by qualified electricians who are familiar with the National Electrical Code, or NEC, and local electrical codes. During inspections, the electrician should check for loose connections, damaged wiring, and other potential hazards. Infrared thermography can be used to detect hotspots in electrical equipment. Hotspots indicate areas of excessive heat, which can be a sign of loose connections, overloaded circuits, or other problems. Addressing these issues promptly can prevent equipment failures and potential electrical fires. Proper labeling of circuits and equipment is essential for safety and maintenance. Circuit breakers and panels should be clearly labeled to indicate the loads they serve. Equipment should also be labeled with its voltage, amperage, and other relevant information. Arc fault circuit interrupters, or FSIs, are required in many areas to protect against arc faults, which can cause electrical fires. FSIs detect arc faults and trip the circuit breaker to prevent a fire. Ground fault circuit interrupters, or GFCIs, are required in wet locations to protect against ground faults, which can cause electrical shock. GFCIs detect ground faults and trip the circuit breaker to prevent electrical shock. In summary, while the National Electrical Code, or NEC, permits loading circuits up to 80% of their rating, it's generally recommended to aim for a lower load percentage for safety, reliability, and equipment lifespan reasons. Consider factors such as voltage drop, equipment lifespan, and potential load increases when determining circuit loading. Implementing strategies such as using current monitors, installing larger circuits, and distributing the load across multiple circuits can help ensure a safe and efficient electrical system. Always consult with a qualified electrician to ensure compliance with the National Electrical Code, or NEC, and local electrical codes. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Electrical work can be dangerous, so it is essential to hire a qualified electrician to perform any electrical installations or repairs. By taking these precautions, you can help ensure the safety and reliability of the electrical system and protect your equipment. Always prioritize safety and follow best practices when working with electricity. Understanding these concepts and adhering to safety guidelines is paramount in preventing electrical hazards and maintaining a reliable power infrastructure. The long-term benefits of a well-planned and executed electrical system far outweigh the initial costs. Firstly, safety is enhanced, minimizing the risk of electrical fires and shocks. Secondly, equipment lifespan is extended, reducing the need for premature replacements. Thirdly, operational efficiency is improved, leading to lower energy consumption and reduced downtime. Considering these factors will result in a more robust and reliable power infrastructure for your server rack installation. It ensures that the electrical system can handle the demands of the equipment safely and efficiently. Making informed decisions about circuit loading, conductor sizing, and protection devices contributes to the overall stability and longevity of the system. By prioritizing safety and performance, you can create a sustainable and reliable power infrastructure that supports the critical operations of your server rack. In the context of a server rack installation, it's also crucial to consider future growth and expansion. The electrical system should be designed with enough capacity to accommodate additional equipment or increased power demands. This forward-thinking approach can prevent costly upgrades or modifications in the future. When planning the electrical layout, it's essential to consider the physical arrangement of the equipment and the available space. The electrical panels, outlets, and wiring should be positioned in a way that is accessible, organized, and compliant with safety regulations. Proper cable management is also essential to prevent tangled wires and ensure adequate airflow. Clear labeling of all cables and connections can simplify troubleshooting and maintenance tasks. Consider the environmental conditions of the server room. Temperature, humidity, and ventilation can all affect the performance and lifespan of electrical equipment. Maintaining a stable and controlled environment can help prevent overheating, corrosion, and other problems. Regular maintenance is essential to keep the electrical system in good working order. This includes inspecting wiring, tightening connections, and testing protection devices. Keeping accurate records of all electrical work, inspections, and maintenance can help with troubleshooting and future planning. Proper documentation can also be valuable in the event of an insurance claim or other legal issues. Building a safe and reliable electrical system requires a team effort. Collaboration between architects, engineers, electricians, and IT professionals is essential to ensure that all aspects of the system are properly addressed. Open communication and clear documentation can help prevent misunderstandings and ensure that the project is completed successfully. By following these guidelines and best practices, you can create a server rack installation that is safe, efficient, and reliable. This will help protect your equipment, prevent downtime, and ensure the smooth operation of your business. Remember to always prioritize safety and consult with qualified professionals to ensure compliance with all applicable codes and regulations. Electrical safety is a shared responsibility, and everyone should be aware of the potential hazards and how to prevent them. Education and training are essential to promote a culture of safety in the workplace. By investing in safety training, you can empower your employees to identify and avoid electrical hazards. Together, we can create a safer and more reliable electrical infrastructure for our businesses and communities. The principles of electrical safety and best practices discussed here are applicable to a wide range of applications, from residential wiring to industrial power systems. By understanding these concepts and applying them in our daily lives, we can help prevent electrical accidents and create a safer world for everyone. The knowledge of these concepts will ultimately make any engineer or technician more capable and confident with electrical installations. The goal is to empower individuals with the knowledge and skills they need to make informed decisions about electrical safety. The aim is to create a world where electrical accidents are rare and everyone can benefit from the safe and reliable use of electricity.